All right, we're finally at a point in this mastery section on confidence intervals that we could build some confidence intervals. And I've got a couple of problems for you that'll allow you to first build the confidence interval, and then in some of the problems to come, do some interpretations of the confidence intervals that you've yet to have done based on what you've read in OpenStax and in the lectures. So let's take them on one by one. This first one, very straightforward. I'm going to do it with the calculator, and I'm going to do it longhand as well too. So this is a study of 90 truckers aimed at trying to understand what the population of all truckers drives on a daily basis. And so what we're going to do is we're going to reach into that population of all truckers, pull out 90, study that sample, and generalize that, make inferences about the population. So it says that that set of 90 truckers has a per day average of 540 miles. And then importantly it says, backs off in a separate sentence, go reread just above, that the standard deviation of the population of truckers, not the sample, the population, is 40. And what it would like is a 99% confidence interval. So that fact that you know the standard deviation of the population drives you one particular way, right? It drives you to a set of formulas. It drives you to this formula right here, that the mean that we're looking for is bound below by this quantity and bound above by this quantity. And what are these quantities? Well, this is the sample mean. Okay, and we are given that that is 540 miles. Yeah. This is the population mean. This is what we're after. This is the quantity that we're trying to estimate or to bound in this confidence interval. And this margin of error for this particular case has the form z alpha over 2 sigma all over the square root of n. And n is equal to 90. Yeah, 90. And sorry, sigma, continuing this, sigma is 40 miles, as we've seen, and we're going to do this for 99%. So let me stop on, I just wanted to kind of write that down to get us going. But in fact, at this point, your calculator can do everything for you. You didn't have to write this down. Instead, you need to turn your calculator on. And in this case, we're going to go to, let me kind of get this progression down for you. We're going to go to stat. Now, once we go to stat, remember that across the top, we can go to edit, calc, or tests. In this case, we're going to go to tests. Yeah, so I'm over to tests there. And now I'm going to go down to number 7, Z interval. Yep. Down, Z interval. And it is then going to ask me a couple of things. It's going to say, what's the input? And what that's asking there is, do I have a list of data to input into a list, or do I just have a set of stats? And you're going to have to enter a set of stats because that will impact what it asks you for after the fact. So I've just inputted stats. Now it says, what is sigma? Okay, and sigma is, as we've seen above, 40, so I'm going to enter that. Then it asks below that, what is the sample mean? And I'm going to enter 540. And then it asks, what is n? And I'm going to enter 90. And then finally it asks for what's the sea level. And I'm going to enter in 0.99. All right, and you know what? I'm going to push calculate, and it's going to tell me this. It's going to tell me that the answer is 529.14 to 550.6. Sorry, 86. Okay, so what is that? That's the confidence interval, right? So what we did, again, reach into the population of truckers, pull out 90, based on their sample, we make an estimate of what the true population average is. And with 99% confidence, we can say that it is between the bounds 529 and 550.86. Into the problem, really, but let me keep torching you. Let's come back here and do this by hand, but really, this is all I want you to be able to do. Remember, this is stat, over to test, send down. Let me show you what has to happen over here. So what has to happen over here is I've got to do a calculation of each one of these things. That means I need to start with a calculation of E, and that starts with a calculation of Z alpha over 2 for 99%. 99%, 1% of the wings, half of 1%, means this is Z.005, and that's inverse norm 0.0501. And let's calculate that real quick. This case, remember, I've got to go someplace else. I've got to go to distribution, down to inverse norm, put in 0.0051 and 1, which I've done, and it will tell me that this number is 2.5758. So now I'm ready to set this up. I'm ready to set up and say that x bar minus E is equal to, what's x bar? 540. What's E? It's equal to 2.5758 times sigma, which is 40, divided by the square root of 90. I've got to get out a calculator that I can actually use and find out what that number is. So I've got 2.5758, 40 times, we've got 90, take the square root, divide, and I've got that this number is 10.861. Okay? So when I affect this subtraction, 540 plus, I get 529.14. Yeah, 529.14. Let's do the same thing now, calculating x bar plus E. That's going to be 540 plus 10.86 plus 10.86, and that's clearly 550.86. Okay, so there's the longhand, there's the calculator. I'll invite you to use the calculator, save you a lot of time, save you from making those kind of calculation mistakes that can crop in there. All right, let's move into some slightly more interesting problems on confidence intervals now.